Okay, all right. So we're going to remember a couple of things. First thing is, in order to compare exponents, we always need the same base. Okay, we need the same base. So if I do not have the same base everywhere, I cannot compare exponents. I must have the same base in order to compare exponents. Now, today is going to require a lot of, somebody's unmuted. I'm going to ask you guys to please.
Did they give you blade at school?
I'll kind of like mute the person from my side. I don't know why.
Yeah, I can't either, so I'm going to remove them. They're going to come back. Unfortunately. Okay, I've removed them. They'll have to log back in. I know, guys, today is just, yeah, it's the weather, guys. The weather's just making everything a lot. I feel like it's cold, therefore, everything must also not work. I don't understand. Okay, so if we look at this first question that we've got over here, what we're going to notice is that none of these bases, except for 2 and 2 here, are the same. But we can change all the other bases to look like 2 and 2 and maybe a 3. Maybe a 3, I think. Yes, we're probably going to find a 3. So let's start with 9. How else can we change 9 so that it has one of the bases that we need? How else can we write 9? Correct, Nkandla, beautiful. We can write 9 as 3 to the power of 2. Excellent. Okay. So here's what we're going to do. We're going to then rewrite everything, but instead of having 9 there, we're going to have 3 to the power of 2 instead. So we're going to have 2 to the power of 4x plus 2 multiplied by 3 squared. Now, because this thing was already there, that x plus 1 was already there, we need to keep it in a bracket there at the top, right? Over, and at the bottom, we've got 3 to the power of 2x times 2 to the power of x multiplied by, now, how else can I write 8 so that it has one of the bases that I want? Correct, good. We're going to rewrite it as 2 to the power of 3. And because that x minus 1 is still there, we're going to put it in there, x minus 1. All right, now, whenever I see brackets, what do I do with this number on the outside, guys? What do we do with that number? What do we do with the number on the outside? Yes, correct. We multiply in. Excellent. We're going to multiply in. So we're going to take these brackets, multiply those 2 over here, multiply these 2, and then we're going to find a new answer. Okay, I'm going to rewrite it now. I've got 2 to the power of 4x plus 2. I like the word distribution, and yes, it's the correct term. Multiplied by 3 to the power of, now I'm going to get 2x plus 2. Okay. In order to become a citizen. I like that. All right. And then on the outside, we're going to get, or on the bottom, we're going to get 3 to the power of 2x multiplied by 2 to the power of x multiplied by 3 to the power of 3x minus 3. Right. That's what we're going to get. Now we're going to notice that we have, at the bottom, we've got like bases being multiplied. Oh, it's a 2. I'm sorry, guys. Sorry, it's a 2. Thank you. Whew. Yo, I almost made a big mistake, guys. Thank you. Thank you very much. It's because Mam's got the flu. Her brain is a little foggy today. Okay, so regardless of that, at the bottom, we've got 2 being multiplied to 2. And when we have like bases, we're going to keep the base and we're going to add exponents. Now, the thing on the top isn't the problem at the moment. We're going to leave the numerator exactly the way it looks, and we're going to fix up the denominator first. Okay, so numerator stays the same, 2 to the power of 4x plus 2 multiplied by 3 to the power of 2x plus 2. At the bottom, I'm going to put the 2's first, so I'm going to get 2 to the power of. Now my bases are being multiplied, so I'm going to keep my base and I'm going to add my exponents. I've got x plus 3x minus 3. What is that going to give us, guys? x plus 3x minus 3. What do we get there? Correct, Tamia. Good. We're going to get 4x minus 3. Remember, Rami, we are adding. We're not multiplying. Okay, we are adding. So we should get 4x minus 3 multiplied by 3 to the power of 2x. Good. Now, we're going to have to focus, please. Yes, the base does stay the same. Isabel, which part do you think, when you say base stays the same, which part are we looking at? Right, please just let me know. Okay, next step is that my bases are being divided. And when my bases are being divided, I'm going to keep my base. And what do I do with my exponents, guys? No worries, Isabel. What do we do with our exponents when we are dividing like bases? We're going to subtract. Mawande, not remove, we're going to subtract. Okay, but I want to show you guys something. What I'm going to do here is I'm going to take 4x plus 2, this top part over here, minus the bottom part. So I'm going to have 4x plus 2 minus, and then I'm going to take this thing here at the bottom and I'm going to put it in brackets, 4x minus 3. Okay, and the reason why I'm doing this on the side is because this is what's going to happen. I'm going to then have to multiply that bracket in. So what I'm actually going to have left is 4x plus 2 minus 4x, and that negative and negative is going to give us plus 3. Give me a thumbs up if what ma'am has just done makes sense. Are you guys with me there? Okay, Chifaro, if you say no, I'm going to ask you to put your hand up and explain where I may have lost you. Okay. All right, absolutely. Okay, so I can repeat. So remember, guys, if I have 2 to the power of 5 divided by 2 to the power of 3, that's the same as 2 to the power of 5 minus 3, right? Which would give us 2 to the power of 2, right? But now if my number at the bottom is already negative, if I have 2 to the power 5 minus 2 to the power of negative 3, here's what's going to happen. We're going to get 2 to the power of 5 minus negative 3. Am I making sense? And that minus and negative is going to give us 2 to the power 5 plus 3, which is 8. Give me a thumbs up if that makes sense. Am I making sense there? Are you guys with me? Okay, cool. So now when we get to the bottom over here, do you guys notice how I now have 2 to the power of 4x plus 2 minus this bottom part? Now this number over here is a negative 3, which means I'm going to get minus negative 3, which is then going to become a positive 3. Have you guys got me there? Does that make sense? For those of you who are like, no, please re-explain, please just tell me, yes, ma'am, I got you, or no, ma'am, so I know where we are. Okay, excellent. Excellent stuff. So instead of minusing that negative 3, we're going to end up adding the negative 3. So I'm then going to have 4x minus 4x, which will give us 0. And what I will have left is 2 plus 3. So my exponent over here is going to be 2 to the power of 5 multiplied by 3 to the power of what? What are we going to get for 3s? No, Sisipo, we don't. You do not do that. We never ever do that, okay? Correct, Jessica, correct, Oratilo, and I'm going to explain why we don't do that in just a second. Good. I know that over here, for the 3s, I'm going to get the top part, 2x plus 2, minus the bottom part, which is 2x. And the 2x and minus 2x will cancel, so I will have 3 to the power of 2 left. Okay. And then you can punch into a calculator, I think it's supposed something like 32 times 9, which should give us a numerical answer. Okay, all right. For those of you who understand me, give me a thumbs up in the chat. For those of you who don't, I'm happy to go over this question again with you. Okay, just give me thumbs up if you're okay. Give me thumbs down if we're like, so that I know who I need to target. Okay, somebody's saying, ma'am, how do we get the negative for the denominator? Zipo, can I ask you to put your hand up, my sweetie, and ask your question to me so that I can kind of understand where you are? You're very welcome, Chifaro. Good. Okay, for those of you who are with me, here is your next sum. Now, remember, none of these look the same. They do not look the same. So I want you guys to make sure that when we are comparing these things, they have the same base. That is your first step. Zipo, how are you doing, my sweetie?
Hello, ma'am.
Hi. How are you doing?
Ma'am, how did
Yes.
you get the negative 4x minus 3?
Okay, because we are dividing like bases. It's like if I said to you, Zipa, if I said x to the power of 5 divided by x to the power of... Hello? Can you hear me?
Yes, ma'am.
Okay, so if we have x to the power of 5 divided by x to the power of 3, what's my answer?
To the power of 5 x to the power of 5.
X to the power of 5 divided by x to the power of 2 is going to give us... For those of you who are following with me, please just answer this question for me. Good, Oratilwe. We're going to get x to the power of 3. Now, I saw somebody's also asking, ma'am, shouldn't we take the 2 and divide them to get 1? No, because we also wouldn't say x divided by x is equal to 1. We wouldn't make this 1 either. We keep the base. We always keep the base. So even if we are multiplying with 2's or we are dividing with 2's, we're going to make sure that we keep the base that we've been given. We do not divide by it. Okay. All right. I just want to double check who was also a bit lost. I need either Tsimuluho or Kanya or Ndumiso to put their hand up so we can talk about this. Okay. Oh, sorry, C. There's no B. Don't worry about B. There's no C. I need one of you guys to put your hands up so we can talk. Bunke, how are you doing, my sweetie?
Hi, ma'am. How are you?
I'm excellent. Are you going to help me with this question?
No, ma'am. I just want to find out about the answer for A.
Yes.
My answer, I wrote 288. Is it fine? Am I supposed to write it out like that because I punched it the way it is in a calculator?
You should. 288. 100% you should. Okay. Finish. Don't even give them to not give you a mark. Finish the sum completely. All right.
Thank you, ma'am.
All right, my sweetie. Okay. For those of you who are still stuck, we're going to try and use this next example as, or this next question as an example on how to answer these questions. Let me just grab my bag. Ooh, guys. The amount of times I'm going to blow my nose in today's lesson, I apologize in advance because my nose is proper clogged, proper, just, it's not lovely. It's not good. All right. Okay, so let's talk about C. Right, now remember guys, if we ever want to compare anything in the exponent, we always need the same base. Now 36 and 18 might have something in common, but what we're going to do is, because we don't know what 36 and 18 have in common, we're going to take 36 and we're going to put it into our calculator and we're going to shift fact. We're going to shift fact. Okay, so for those of you who don't know how to do this, take your calculator, click in the number 36 and then click equals. So 36 equals, and then you're going to go click the shift button up here, shift And then you're going to look for a button that has like a lot, there is like a dot, and then they're like commas, dot, dot, comma, comma, comma. And up on top of that, there's the word fact there. So if you click on it, it will give you the factors of 36, which are then going to be 2 to the power of 2 times 3 to the power of 2. Now, the thing with this is, on top of that, oh, patience, we don't do 6 to the power of 2 because that's not going to work for 18 either. Good, we're going to get 2 to the power of 2 times 3 to the power of 2. But on the outside of this 36, there was a 3x plus 4 on the outside. And then we were going to say multiplied by, now we're going to go to our calculator and we're going to do the exact same thing with 18. Okay, we're going to do the exact same thing with 18. So we're going to click 18 equals, shift, and then the fact button. And our calculator tells us that 18 is 2 times 3 squared. But we still need to take this, because it already came with its own exponent, we put the exponent on the outside to the power of negative 4x. Okay, and now we're going to do the exact same thing like what we did with the questions above. Okay, first thing I always like to do is, if there's ever a number sitting on its own, I always give it an exponent of 1 to make sure that I don't forget that I'm actually multiplying that exponent as well with the number 1. Do not forget that, guys. So rewrite this as 2 to the power of 1. Make sure. All right. Then what we're going to do is we're going to distribute. We're going to take the whole of 3x plus 4 and multiply it with that 2. The whole of 3x plus 4 and multiply it with this 2. Then over here, we're going to go to negative 4x multiplied with 1 and take the whole of negative 4x and multiply it with 2. All right. So here's what we're going to get next. This is going to equal 2. I'm going to start with this first 2 that I have over here. 2 to the power of 2 times 3x will give me 6x plus 2 times 4 is 8. Multiplied by, I'm going to use a dot instead of a times. Okay, I'm going to use a dot. But they both mean the same thing. Multiplied by 3 to the power of 2 times 3x, which is 6x, plus 2 times 4, which is 8. Multiplied by, now we're on this side over here. We're going to do the exact same thing. 2 to the power of 1 times negative 4x will give us negative 4x, multiplied by 3 to the power of 2 times negative 4x, which is negative 8x. I want you guys to give me a thumbs up in the chat if you're okay with all the steps that Teacher Coco has taken from this point on. Are we all okay with the steps that ma'am has taken? I'm sorry, guys. Oh, excellent. All right. Now, the only thing left to do is to compare like bases. Now, I know that my like bases are not going to be all of them. I can only compare 2 and 2. And then once I'm done comparing 2 and 2, I then compare 3 with 3. But my like bases are being multiplied. So I'm going to keep my base. So I'm going to put a 2 down, and then I'm going to add my exponents. Now over here, I've got 6x plus 8 plus minus 4. Now that plus minus is going to give us a minus. So what we're actually doing is we are minusing. So what are we going to get as an answer? I'm going to get 6x minus 4x plus 8. What is my final answer for my exponent? We are using this one plus that one. Correct, Jessica. Beautiful. Excellent. It's going to give us 2x plus 8. Multiplied by what? What are we going to get? We're going to get 3 to the power of, now my 3's are also being multiplied. So we are going to then compare exponents. We're going to add exponents. Now I've got 6x plus 8 minus 8x will give us how much? Negative 2x plus 8. All right. Okay, good. Don't forget the 8, and Claire, it must come with, okay, negative 2x plus 8. All right, beautiful. Give me a thumbs up, guys, if you're with me here. Are we all together on how ma'am reached this answer? Are we good? Beautiful. I'm glad everybody's with me. All right, let's, you know, we're going to skip that one for now. Let's do B. We're going to do B first, and then we'll come back to C. Okay. Yeah, let's do B. We will come back. Bunka, actually, we're supposed to change the negative 2x to a positive exponent, but I'm afraid it might trip us up. So I'll come back to it at the end of the lesson. Okay. I don't want us to get lost. Let's do this B over here, B number 2, because there's so many B's. There is B right over there, guys. Okay. Isabel, let me see. Would we not change? No. No, we wouldn't. Okay. So Isabel, if we want to make a base of 6, my exponents need to look identical. They need to look exactly the same. Do they look exactly the same? No, they don't. The other one is 2x and the other is negative x and negative 2x. So they're not the same. If this one was also 2x plus 8, then we could multiply them and give them the same exponent. Okay, but in this case, no, there's a negative there, so we can't do that. Refilwe, what's up? Hi, Refilwe.
Hi, ma'am. How are you, ma'am?
I'm good, thank you. How are you?
Ma'am, not that I really know what to do now, but I like to help on the next question.
Absolutely, let's do it. Oh, I love it. Yes, okay. So we know, Refilo, if we want to compare exponents, what must we have? The same what?
The same base.
Correct, we must make the same base. Right. So we need 125, 25, and 25 to have all the same base. What base can we pick here? What do you think?
I think 25.
We could choose 25, but I'm not going to get 25 to the power of anything is equal to 125. That's not going to work. 125 won't work. I mean, won't work with 25. Any other number? Yes, and Mfundo says, because yes, shift fact would work. Right, it would tell us. So 125 will give us 5 to the power of what?
Can I quickly check, ma'am?
Sure, do shift fact on your calculator. Punch into your calculator, 125 equals shift fact and tell me.
Shift. I will, ma'am. How do you do that?
Okay, first, okay, clear your calculator,
Yes, ma'am. Yes, ma'am.
Type in 125 and then click equals.
125. Okay.
And then click shift and then look for the button that says fact.
Oh, I see it, ma'am. It says 5 to the power of 3.
That's it. 5 to the power of 3. But remember, on the outside, there's already an x, right?
Yes, ma'am.
Okay. Multiplied by, how else can we write 25? We wanted to have a base. What's that going to be?
5. It's going to be 5 to the power of 5.
Ooh, no, not 5 to the power of 5.
Oh, to the power of 4, I think.
Punch
Let me check.
Do 25
fact. Shift fact. 5 to the power of 2, ma'am.
Good, 5 to the power of 2, but don't forget, Refilo, there's still that x minus 2 on the outside. X minus 2. And then we also know 25 can be written as 5 to the power of
5.
We just did it now. 25, 5 to the power
of 2.
5 to the power of 2. Good. Okay. So now what we have to do is we see a bracket and an exponent. So what are we going to do with this outside exponent? We must
times.
All right, we must times these. And don't forget this one as well. We must distribute that 2 to both. Okay. So what am I going to get? I'm going to get 5 to the power of what?
3x.
Good. 5 to the power of 3x times 5 to the power of, what are we going to get over here?
Negative 2x.
Remember, you must multiply them one at a time. 2 times x will give us?
2x.
Good. 2x, and then 2 times negative 2.
This is gonna give us negative 2x. Or
Not
2
negative.
times negative 2.
Uh-huh.
It's gonna give us negative 4x.
Not 4x. There's no form. There's no x, Masudi. It's just
Oh,
2 negative
negative
2.
4.
Just
Okay,
negative
ma'am.
4. Just negative 4 is equal to 5 to the power of 2. Now, Refile, as soon as my bases look the same and we're multiplying,
Yes,
what do we
ma'am.
do with the exponents? When I'm multiplying the same base, what do I do with the exponents?
We add them.
Correct. We're going to keep our base and we're going to add the exponents. So tell me, what is 3x plus 2x minus 4? 3x plus 2x will give us?
5x.
Good. And the minus 4, don't leave it behind. It must come with us. Minus 4 is
equals
equal
to
to
5
5
squared.
Correct. Now that my bases are the same, I can drop them. I can drop this one and drop this one. Now my equation is just going to be the exponents, Refile. I'm going to get 5x minus 4 is equal to how much?
Is equals to 2.
Correct, 2. And now we can solve for x. Okay, how do we solve for x here?
Yes, ma'am. We take the 2 to the other side.
We take the 2 over to this side. We're trying to solve for x. We need to isolate the thing with the x. What do we need to get rid of?
I mean, we take the 4 to the other side. So it's
Not
gonna
just
be
4, what? It's not 4, it's?
negative 4.
Correct. So when it goes over to the other side, it will become?
Positive.
Good. So I'm going to end up with 5x is equal to 2 plus 4 gives us?
Plus 4, 6.
Good. What's my next step?
We divide both sides by 5.
Beautiful. Divide both sides by 5. Very, very wonderfully done. X is equal to 6 over 5. You are a whole genius. Look at you. You managed to finish that whole sum. Well done.
I
Well done.
tried, ma'am.
Love it. No, I absolutely love you for trying. Don't forget the shift fact thing. It's very important, especially when it comes to exponents. Okay.
Yes,
Remember
ma'am.
it. All right. Thank you, my sweetie, so much for helping with that question. Thank you so much. Love, love, love it. Guys, please, guys, you must have the same energy that Refilwe has, guys. You must try things, try them. All right, let's do this next one over here. Let's do A down here. We'll come back to that other one in just a little bit. Let's do A. Remember, guys, same base. We need the same base everywhere. Yes, Bunke.
Ma'am, for me, the second step.
The second step.
I don't know if it's going to be a problem in the exam when I write it as 5, 3, and then I just put the x in a bracket, not like 5 to the power of 3 and then 5 to the power of 3 in bracket and then the x is outside. Because in the end, I still get the same answer.
It's fine. Remember, multiplication is brackets. So even if I do this, if I go 3 multiplied by x, or if I go 3 multiplied by x, it's the same thing. We need to multiply in either case. So it won't make a difference, my sweetie, as long as you give the correct answer. Okay.
Okay, thank you, ma'am.
All right, you're very welcome. Okay, let's give this one a second. And now I'm saying a second because I saw Teacher Nels right. Give me a minute in the chat. Let's give this one a try. When you're done, yes, I will, Patience. I've given you some time. When you're done, pop your favorite emoji in the chat, and then we'll take it from there. Oh, thank you guys for helping, because I don't even know what kind of calculator Anotida has. I'm sorry, guys. I'm sorry, Anotida. I don't know how to help you. Mpobonelo, are we doing okay? Give me a thumbs up, my sweetie. Nompumelelo, are we okay? Excellent, my sweetie. Keep going. Yes, Mfundo, that is 100% correct. Sorry, guys, I'm just going to mute and blow my nose for the 100th time. For those of you trying to help Anotita, please make sure that you're also prioritizing your own work. Okay, Katela, I'm not sure yet. Okay, Jessica, that's fine, my sweetie. Wait for me, and then we'll do it together. Okay. Is it not at all, teacher Nels? Okay, I will show Anotita. Anotita, if your calculator doesn't have that function, I'm going to show it. Okay. Okay, that's fine. Okay.
No, I don't see it.
At all.
No, at all.
Okay, I will show Anotita how to do it manually in just a second. Thank you, teacher Nels. That's okay. No, Mawande, don't say that. Yes, Abigail, but there's an easier way for you to do it, and I'll show you. The ladder method is a bit, yeah, but yes, you can use the ladder method, but I'll show you how. All right. You're just going to have to be really good at exponents. All right, let's start over here, guys. Now, remember, whenever we want to compare exponents, we need the same base. Now, my 5 is already a prime number, so I'm going to leave it the way it is. I'm going to leave it as 5 to the power of 2x minus 1. What did we do with the 9? What did we do with 9 over here? What did you guys do? Multiplied by? What did we do with 9? Good, Chifaro. We made it 3 to the power of 2. Excellent. So 3 to the power of 2. And again, I'm going to put brackets around it because on the outside, there's still x minus 2. All of this over. Yes, patience? All right, all of this over. Now, we know we can rewrite 15 as 3 times 5. Right. But this still has x minus 3. Outside. Now we have a bracket and an exponent, guys. We are going to distribute. And over here, we also have a bracket and an exponent. What are the exponents of 3 and 5 here? What are the exponents for each of them? Correct, Abigail. That's it. Yes, Mawande. This one has an exponent of 1. This one also has an exponent of 1. So we're still going to distribute each of these to the bracket or to that 2x minus 3 on the outside. Okay, now let's clean up our sum. We're going to get 5 to the power of 2x minus 1 multiplied by, if anybody wants to jump in and volunteer to finish this sum for me, I'm happy to have you. But I'm going to continue. Yes, patience. I love it. Yes, patience. Okay. Let me get my...
Okay, ma'am. We're going to have 5 to the power 2x minus 1. Then 3 times 3 to the power 2x minus 2.
Not minus 2, minus what? 2 times negative 2 would give us?
3 times 3 to the power 2x minus 4.
Minus 4, correct. Minus 4, beautiful. Over, what are we going to get at the bottom?
All over 3 to the power 2x minus 3.
Times?
Yeah, all over 3 to the power times 5 to the power 2x minus 3.
Excellent, good. Now, patience, I have a like base here and a like base there. But my like bases are being divided. So what am I going to do with my exponents?
You're gonna add.
We are dividing. We only add them if we're multiplying. If we're dividing, what do we need to do with the exponents?
Subtract them.
Correct, we're going to subtract. I'm going to do it over on the side here so that we don't get lost. Okay, so I'm going to say, give me 1 second. I'm going to say 2x minus 4, the top part, 2x minus 4 minus the bottom part. Do you agree with me? Minus x minus 3. Now, patience, if I distribute this minus in, what am I going to get? I'm going to get 2x minus 4 and then
2x minus 4 plus
minus 2x plus
3.
plus 3, correct. Plus 3, good. So we now know that 2x minus 2x is going to give us 0. Yes?
Yes.
Good. Now I have minus 4 plus 3 left. What is minus 4 plus 3?
Negative 1.
Beautifully done. Negative 1. Amazing, amazing, amazing. Times. Now we are only done with the 3s, patients. We still need to do the 5. So let's go and do 5. 5 is also being divided, right? So what are we going to do with the exponents?
I'm gonna put them on. Ma'am, can you do them? Just
Okay.
like
Okay, good. I'm going to minus them, right? Because we're subtracting, I must minus, right? So I'm going to have 2x minus 1 minus, and then I'm going to open brackets and I'm going to put in there 2x minus 3, right? Then what am I going to do over here, patients?
I'm gonna have 2x minus 1 minus 2x plus 3.
Beautiful. Oh, love, love, love it. 2x minus 1 minus 2x plus 3. So we know that 2x minus 2x is going to give us 0. They're going to cancel. Yes. Now I have minus 1 plus 3 left. What is minus 1 plus 3?
2.
2. Beautiful. Okay. Now I don't have any more x's in my answer. So I'm going to punch this into my calculator. What answer do I get?
Ma'am, can you wait a bit? Negative 1 times. Ma'am, it's
How much
giving
of-
me 8.33.
25 over?
Over 3.
Beautiful. And you've just gotten 100% of the marks. Yes. 100%. Just wow. Beautifully done, my student. Well done. Okay. Very, very well done. Oh, sure. Just
So, ma'am, do we leave it like this?
yes, we must, yes, because there's nothing else we can do. 25 and 3. Yeah. Okay. All right. Well done, patients. You did so, so well. Very, very well done. Okay, somebody's asking, do you have to change the negative exponent to a fraction first? Yes, especially if they say without the use of a calculator. We know that anything with a negative exponent, we put it over 1 and we flip it. We flip it and it becomes part of the denominator. So yes, I saw Lulu asking, ma'am, wouldn't this process take too long? Yes, it does, Lulu, but the quicker you get at exponents, the less you're going to need to use these things. Next time, when you're really, really fast as at exponents, you won't have to do this step. You can skip the step and go straight to the answer. But for now, to make sure we don't miss anything, I want to make sure you guys see the step. Okay, Siamtanda, what's up?
Ma'am, I just have a question about the answer. So if you change it into decimal form, is it going to be wrong?
If you changed it to?
Decimal form.
A small?
Decimal.
Oh, decimal. Yes, especially if they say calculator. If they say no calculator.
But
okay, if they say no calculator, you give it in decimal form, then yeah. Because I'm thinking, what would it be in decimal form if you didn't have a calculator? Let's see if you could actually figure it out. This would be 6 and 1 over 3. So 6.3 recurring. Okay, yeah, I mean, you could do it, yes. You could do it. I don't think they'd mark you down because if you're able to see it logically, yes. Okay. Yes, I think you should be fine. You should be fine. But just for the sake of accuracy, leave it as a fraction. Okay.
Okay, thank you, ma'am.
You're very welcome. Good question. Good question. I see somebody. So, ma'am, do we have to subtract every time the sum divides? Yes. Yes, we do. Okay. Jessica, what's up, my sweetie?
Hi,
Because I want
ma'am.
us a little bit more difficult. Hi, my sweetie.
Can you use your calculator if you want to be quick and don't want to do it on paper?
Just say that one more time for me.
For the first step, if you do the first step by dividing the 9 and making it in
Yes.
the 3, can you to be quicker and solve the question faster, you can use the calculator.
Okay. All right. So do you find that way a lot easier to solve and quicker to solve the question?
Yes, ma'am, because in the test, they
perfect.
don't give a lot of time.
Okay, if that works,
just for the first part where you break down the numbers, the big numbers.
Yes, that's perfect. Look, I'm just taking it slow, Jessica, so I don't leave anyone behind. Okay. So if you can do it faster in your head and you already know the answer, go ahead and do it. I just want to make sure I don't leave anyone behind. Okay. All right, my sweetie.
Thank you, ma'am.
Excellent. You're very welcome. Good question. By the way, guys, if you know the shortcuts on how to get to the answer better, okay. All right. Oh, yes, we do that on Wednesday. Thank you. All right. Okay, let's look at this one. Now, guys, we're going to notice in this particular question, we are not multiplying, right? I mean, there is some multiplication involved, but there's a plus here and a plus there. As soon as we see a plus or a minus, the first thing that should come to mind is split and factorize. Split and factorize. Okay, so I'm going to do this very quickly because we're going to run out of time. But here's what we're going to do. I'm going to split this, guys. If I have 3 to the power of 2 multiplied by 3 to the power of x, this is the same as 3 to the power of 2 plus x. Now, what I'm going to do is I'm going to do this in the opposite direction. I'm now going to take 5 to the power of x minus 1, and I'm going to split it into 5 to the power of x multiplied by 5 to the power of minus 1 times 11 plus, now I'm going to do the same thing with 5, with the 5 to the power of x plus 1. I'm going to split it into 5 to the power of x multiplied by 5 to the power of 1. Thanks. Okay, divided by, let's go to the bottom, guys. We're going to do the exact same thing at the bottom. We're going to go 5 to the power of x plus 5 to the power of x multiplied by 5 to the power of minus 1. Okay, Lulu, let's think about this. Okay, if I say to you, I've got 5 to the power of x plus, if I said I have 5 to the power of x multiplied by 5 to the power of 2, my like bases are being multiplied. So I'm going to keep my base and I'm going to add my 2 exponents, 5 to the power of x plus 2. Do you understand that part? Give me a yes, ma'am, in the chat if you're with me there. Okay. Are we all good? We do not cancel, not at all. Lulu, are you with me here? Okay, Refilo says, yes, ma'am, I'm going to assume that we're all together. Good. Now, what I'm doing, Lulu, is I'm doing it in the opposite direction. So what I'm now doing is instead of having this, I'm going to do it in the other direction. I'm going to go 5 to the power of x plus 2 is equal to 5 to the power of x times 5 to the power of 2. I'm just doing it in the reverse. I'm doing the reverse of what I've just done. Okay. All right. So that's what I'm doing. Yes, I'm separating. That's the split part. That's the split part. We've now split it. Okay, we've split it. Now what we're going to do, guys, is we're going to factorize. Now, remember, guys, if I said to you guys that I've got, if I've got 2x squared plus 4x, I need to factorize. I would take out the common factor. What is my common factor here? What is my highest common factor? What is my highest common factor? Good, not just the 2, guys, 2x, 2x, all right. Because, and we know that we're taking 2x out of both because there's a plus in between them, right? Now, if let's go back to this example that ma'am's done here for you. Between this term and that term, what do they both have in common? What is this term? What is the highest factor between these two? Between on the top, what do they both have in common? Anybody see it? Correct, 5 to the power of x. Good, 5 to the power of x is here and 5 to the power of x is there. So we're going to take 5 to the power of x out as a common factor. We're going to go 5 to the power of x, and then I'm going to open brackets. What do I have left? Anybody want to put their hand up and tell me what do we have left? Ooh, we're actually out of time. Right, I'm going to get 5 to the power of minus 1 times 11 plus 5 to the power of 1. Give me a thumbs up in the chat if you agree with me on this answer that I've got here. Are we all together? Thank you, teacher Nels. I've got 1 second. All right. Excellent. Excellent. Now at the bottom, what are we going to do at the bottom? What can we take out at the bottom? Look at the denominator, guys. What do we see at the bottom? Good. Oratile. Also, we're going to factor out a highest common factor of 5 to the power x. Let's take out 5 to the power of x. Open brackets. Now, if I've taken 5 to the power of x out over here, what do I have left? What do I have left over here if I've taken 5 to the power of x out? It's not nothing, correct. No, it's just 1. Good, Nkandla, it's just 1. It's not going to be anything, guys. It's like if I had 2x squared plus x. If I take x out as a common factor, I'm going to end up with 2x plus 1. Okay, that's why Oratile. So because I've taken out the whole thing, I've taken out the whole x, I must put a 1 in its place. Okay, that's how we factorize. So this answer over here is going to be 1 plus 5 to the power of negative 1. Close brackets. All right. Now that I've factorized these out, now that they're being multiplied to each other, now I can cancel the 5 to the power of x. I can cancel this 5 to the power of x and that 5 to the power of x. Right, now the only thing left is take everything that's left because there's no x's, punch it into a calculator, give me an answer. Okay, Refilwe, I'm going to have to explain to you again. I'm going to have to explain to you again on Wednesday, okay, because we are out of time, but I will do one more example with you guys on Wednesday,